This is absolute genius. Dive into a world of action, adventure, and explosions.
Each show will introduce you to a different genius.
An amazing person who had a genius idea which shaped the world.
And they will inspire us to come up with our own genius idea at the end of each show.
But will it be any good?
Will it be any good?
It'll be absolute genius.
On today's show, we prepare for deep impact.
Yeah, look at that.
As we investigate the mysterious world of comets. It's a comet!
And discover how a genius astronomer helped to map out the universe.
This way a bit. All right, don't help. Come on, over the gap. Whatever you do. Got to be able to see up there. Yeah. That's it, sorted. All right. Today, we're going to introduce you to a person who changed our view of the world. Sorry, the universe.
Yeah, she was one half of a brother and sister team that unlocked the secrets to deep, deep space.
From building telescopes to discovering comets and even a new planet.
Right, try and find her.
Oh, yeah.
Right.
Ladies and gentlemen, we give you... Have you found it yet?
No.
Got it?
Got it.
Gooey boys!
Caroline Herschel.
Now, inspired by her genius, we're going to be creating our own genius idea later on in the show. It's going to be an out-of-this-world tribute to Herschel.
No, he's coming straight for us! But first, let's find out how it all began. Today, powerful telescopes help scientists capture the most amazing images of the universe.
But more than 250 years ago, people knew far less about space. Not every planet we know about now had been discovered.
Astronomy was exciting and full of mystery, and it was about to change the life of a young girl called Caroline.
Caroline Herschel was born in Germany in 1750 into a life of pain and misery. Childhood diseases like typhus left her with scars and stunted her growth.
Because of her appearance, her parents thought that no one would want to be with her for the rest of her life, so they made the decision to keep her at home as the family maid.
You finished it? Get a move on!
How awful.
Ugh, what a stinker!
But when she was 22 years old, she was brought to Bath in Somerset. Rescued by her favourite brother William, a professional musician and keen astronomer, together they would explore deep space.
Can you believe that this house here would become Britain's version of the NASA headquarters? To tell us more, it's genius helper Joe Middleton from the Herschel Museum of Astronomy.
Hey, Joe.
Hi, Tom. Very nice to meet you.
All right.
Nice to meet you.
Hi Joe, lovely to be in the Herschel's house, but what did they do here?
This was the place where they actually designed, built and made their own homemade telescopes to actually stargaze and really change what we know about the heavens.
The Herschels wanted to see into deep space more clearly. So William designed, and together they had built the biggest and most high-tech telescopes of the time.
Their telescopes were the Rolls-Royces of all the telescopes.
Yeah.
They were the best that you could get.
Yeah, so it's kind of like finding your next door neighbour was making Formula One cars in his shed. They were making the best stuff around.
What was Caroline's role in this house though?
As an amateur, William decided to do his own surveys of the night sky, and he needed Caroline's help. So she would do all the paperwork, record it and document it for future generations.
The Herschel's genius helped us map out the universe. They made their own telescopes to see further into deep space. William famously discovered the planet Uranus.
And his astronomer sister Caroline became the first woman to spot one of the most mysterious objects in our solar system.
No, not that.
A comet.
Thank you.
And not just one, she went on to discover 8 of them. Genius.
Oh, and very pretty too. Woohoo!
What's so important about discovering comets?
Well, comets were just one of the real sort of dynamic things to see in the night sky.
Yeah, I
So
remember when I was
suppose-
a kid I saw one. Halley's Comet.
Yeah.
That's a famous one, isn't it? I saw
And
that.
so to stake claim that you discovered a new comet would just make you an instant celebrity.
Ooh, cameras!
Caroline held the world record for the most comets discovered by a woman for almost 200 years. She also became the first female scientist in Britain to be paid for her work.
It says the tail of the comet.
Very neat handwriting, isn't
Very
it?
neat. It looks like she's had a ruler.
Yeah, it does. Read it, read it, read it.
The most brilliant phenomenon that accompanied a comet in the stream of light, which we call the tail.
Her handwriting is actually meticulous. It is so perfect. That is beautiful.
Yeah, I have nice handwriting. What about the astronomy?
We want to discover our own passion for astronomy, so we've come here to a house on the Wirral.
I love the Wirral. The Wirral, the northwest of England. Location for the M53 motorway and childhood home to Bond actor Daniel Craig.
But we're not here to spot Hollywood superstars, no.
We're here to explore the wonders of the universe.
Yep, we're going stargazing. With genius helper Brendan Martin and his mates Dave and Jeff from the Liverpool Astronomical Society.
Just like the Herschels, they build their own telescopes.
The proof is in the back garden. It's full of home-built observatories.
Brendan and the guys are letting us borrow one of their precious handmade telescopes. It works in a similar way to the Herschel's telescopes and took 3 years to build.
How does this telescope work then?
The light comes down, hits this mirror, then it's reflected back up to this secondary mirror, which is at a 45-degree angle,
Yeah.
and that sends the light out to the eyepiece.
Why is amateur astronomy so important?
We search for supernova, the death of a massive star. The professionals who used to do this don't have the time anymore. So what happens is the amateurs discover them, and then they can let the professionals know, and then they can turn their telescopes onto them.
So you're like the professional secret spy unit.
There are amateur astronomers all over the world, just like Brendan. Using modern telescopes, they capture amazing images, often making new discoveries of their own.
Ah, the M45 star cluster. Yes.
So you built this with your fair hands and you're going to trust us with it?
I'm going to let you look through it.
Yeah,
Right.
okay. That's it. Don't let us anywhere near that very lovely mirror. And while we prepare for a night of stargazing, here are some top facts about the solar system.
It's the Genius Top 5.
At 5, more than 100 spacecraft have been launched to the moon. It's still the only place in space that humans have landed on, stepped onto, and explored.
I'm king of the moon.
4. The furthest galaxy detected from Earth is about 30 billion light years away and goes by the catchy name of Z8 GND 5296.
3. Jupiter's Great Red Spot is a gigantic storm, about the size of up to 3 planet Earths, and it's been raging for hundreds of years.
At 2, more than 200,000 people have applied for a one-way ticket to Mars. A Dutch engineer is asking for volunteers to set up a human base on the planet. Problem is, if you change your mind, there's no way back.
And at 1, apart from the 8 planets in our solar system, there are more than 500,000 registered minor planets, 17 of them called Dave, and 1 called Dick. I always said he was on another planet.
Right. So, because it's night time, we've of course, as you probably realised, got night vision.
Right, let's go and have a look what we can see.
There we go. If you want to have a look at that.
You've
this
spotted
is-
something already?
Yeah, it's a globular cluster.
A
called-
what?
Globular cluster.
Globular, I can't even say
What's
it.
a globular
cluster.
cluster?
It's a collection of stars, about 33,000 light years away.
33,000. It's incomprehensible to think about how far away that is.
The M13 cluster is home to more than 100,000 stars. So huge it spans 150 light years, each light year equal to around 6 trillion miles.
Amazing. Come and have a look. Hey, look. It's there, look, in the middle. And how big are each one of these stars that we've
They
seen?
vary in size.
What's the biggest?
And there's probably around 20 solar masses, possibly more.
So
Oh,
the size of...
compared to our sun?
About 20 times the size of the sun.
What?
Wow.
We're looking at some stars, and some of them are 20 times the size of the sun.
Yeah, but get this right.
The
in your
sun
head.
is how many times bigger than the Earth?
1 million.
What is it? What? Hang on. What is it? It's a massive ball of fire. Just floating around in space. What's it doing there? What's it think it's doing?
It's making me feel quite uncomfortable. Very hard to get your head around the universe, isn't it?
It is, can be.
How important was the work the Herschels were doing at the time?
Well, it was very important because they were actually cataloguing everything they saw and marking its location in the sky to make it easier for other astronomers around the world.
I think we can now realise why the Herschels were getting so excited about what's up there.
What is up there?
We've been blown away by seeing the M13 globular cluster, but Caroline was searching for something even more spectacular: comets. Which leads us to one burning question.
What are comets?
I don't really know.
Fran?
This is Fran. She just loves experimenting to help explain the ideas of our geniuses. And she's sure to pop up just when you really need her.
Fran, quite a big question here. What is a comet?
Okay, well, a comet is like a cosmic snowball that zooms around the sun, orbits around it, sometimes going really close to the sun and sometimes far away. Now, comets are actually made from the leftover stuff from the solar system after the planets and the moons and the sun formed.
So, like when someone's building a house, they've got a load of pile of leftover bricks.
Yeah. That is a comet, but I thought the best way to show you in detail what it's made from is to make one. So Dick, can you pour that water into here? This is where I'm going to make my comet. Oh, these are smelling salts. Do you know about smelling salts?
Not really. It's something to wake you up, is it?
Yeah, have a sniff. Shake that ammonia in. A comet can be quite rocky. So we've got some sand there to represent those rocks and minerals right inside that comet's core. Now, the exciting thing about comets is they contain what are known as organic molecules. Now, organic molecules are molecules that contain an element known as carbon. And soy sauce, surprisingly, has a lot of organic molecules.
Oh, soy sauce.
So can you give a good dollop?
How much?
A good shake, let's say. Now, the other thing that comets contain are amino acids, and amino acids make up proteins. So we've got some amino acids here. So give a good sprinkle of those into our comet. You might see on adverts that shampoo contains amino acids, apparently.
Yeah.
Yep, so we've got some shampoo here.
My turn. Get off.
That's it, that'll do. This last ingredient will freeze it down quite quickly into what is hopefully a dirty snowball.
Yeah.
But it's pretty dangerous, so we need to pop our goggles on.
goggles.
So put your goggles on your face and your gloves on. This is dry ice.
Oh, yes.
Which is frozen carbon dioxide. So this is at minus 80 degrees Celsius. And so hopefully when we put it in here, it will cause the water to bubble away a little bit, right?
Okay.
Just like...
Harry Potter style.
Here we go. So let's get that in. Now what I want to do is...
All right, Fran.
Can you see it?
I can see that.
I'm trying to squeeze of all the ingredients together.
So, just that bit of dry ice will freeze the contents of that bag?
Hopefully.
Right.
Yeah, you can.
You see it bubbling around. He's trying to think that might be ready.
We've got a dirty snowball.
Hopefully.
Let's have a look. It's a comet.
A comet. Now, this is a comet's core, but most of the pictures that you might have seen of a comet, they have that sort of rocky bit in the middle, but then that beautiful tail coming out from behind it. And that happens when they go near the sun and they're heated up by the sun. And so all of the ice that's in the comet's core is turned into a gas, and so that's all the gas trailing behind the comet that you see.
Wow.
And can you see just there. Can you see that gas coming out?
Yeah.
That's like our comet's tail.
Can I hold it?
Yeah, of course you can.
Do you know what this reminds me of, Fran?
I don't think I want to know.
Your brain. Brilliant. Comets travel in a big loop, from the icy edges of the solar system, round the sun and back again.
When they heat up, they release dust and gases. The comet tail Herschel wrote about.
But you have to be patient to spot one. Some, like Halley's Comet, pass Earth once every 76 years. Others take thousands of years.
We need to know more about these dirty great snowballs. We've come to the Royal Observatory in London to meet genius helper and astronomer Liz Roach.
Hey, Liz.
Hello.
How you doing?
I'm good.
Now, we've had the pleasure of making our very own comet, which is really interesting, but we need to know a lot more about them. You have one here in this amazing
Or a
place
bit of
to
one.
touch.
Yeah.
Bit of one. That would be brilliant, but unfortunately, no, we can't. Because if comets ever do come to Earth, they kind of just evaporate and there's nothing left to look at apart from the big hole that they leave behind. But there are other things that were around at the time when our solar system was forming that we can touch, like this one.
I was about to say, you're not talking about that massive hunk of rock right in front of you, are you?
Yes.
What is this?
So this is a meteorite. So this is a chunk of an asteroid that probably broke off, and then as it comes through our atmosphere, we call it a meteor, and if it lands to Earth, that's when we call it a meteorite.
And how old are we talking for these comets and asteroids?
As old as our solar system. In fact, even older than our solar system, because they're left over from when it formed.
So
4.5 billion years old. This is the
4.5 billion?
oldest thing you will ever touch.
Unbelievable.
What kind of damage could a comet do if it hit the Earth?
I mean, you've only got to look at something like the moon to really see the kind of damage that can be done by space rocks hitting into something, because our moon is covered in craters, and
so
that's how that was done.
Those
from
craters
comets?
are... Wow, right.
But they've
never knew
come
that.
from lots of different things that would be in space, so things like asteroids and meteors and possibly comets as well, so all sorts of things just crashing into it.
So the moon gets a fair old battering, doesn't it?
It has done over the years.
If that's the kind of damage comets can do, you would not want to get in the way of one. But how likely is it they could hit us on Earth?
To get the lowdown, we're meeting genius helper Dr. Gareth Collins from Imperial College London. He knows all about the damage caused by objects hitting us from outer space.
Hi, Gareth.
Hi, Gareth.
Nice to meet you.
All right. So, how often do smaller objects actually penetrate the Earth's atmosphere?
Well, we're hit by pebble-sized things all the time. In fact, if it's a clear night and you're lucky, you'll probably see a shooting star, which is something about that size burning up in the atmosphere.
No way. Okay, so how long before we get an asteroid or comet the size of a city?
That is a truly rare event. That probably only happens every once in 100 million years.
Ah, thank goodness for that. Looks like we'll all be safe for a good few million years yet.
Hey, great idea for a science fiction movie, though.
When was the last one?
65 million years ago.
And what kind of damage would that do?
When they slam into a planet, it's like a huge explosion. Comets are travelling incredibly fast, probably about 40 kilometres per second.
What's that in miles an hour?
That's 100,000 miles per hour.
That's 100,000 miles an hour?
Or 200 times the speed of a jumbo jet.
Wow.
200?
Now, have you got some kind of experiment that you can show us that will give us an idea of the damage that gets done by one?
Well, we can't get up to 40 kilometres a second.
No.
But what we can do is fire this cannon.
To safely provide the firepower, we've enlisted the help of Worcester Norton Shooting Club and their cannons.
Well, here's Bob and Trev, our mini cannon experts. OK, boys, so you think you can put a crater into that clay there with that?
Well, yes, we think so, yes. If we use the proper ammunition for it, which is like a lead ball, it'll put a hole through that.
What are you going to use then? What's the ammunition?
We've raided the bushes and we're using rose hips.
Hey?
So that is our comet, a biodegradable comet.
Well, actually, it's a great representation of a comet. It's low density, and just like a comet, it's going to explode on impact.
Right, Bob and Trevor, do your stuff.
The cannon is primed with a small amount of gunpowder.
Look at that, it's a perfect fit.
Oh no! Instead of a lead ball, we're using a rose hip, which should break up like a comet on impact. All you need is an absolute idiot who's willing to light the thing.
Looks at me.
Fire in the Woohoo!
Yeah, look at that! Wow! Beauty!
Yeah, this is great. We can see some quite characteristic features of craters here. We have the impactor completely broken up.
Yeah.
A raised rim of material thrown out of the
Just want to say, this is something you see on a lot of lunar movies and all the footage from the original moon landing.
Very characteristic of impact craters.
That's great. Can we do it again? Can we do it again? Yeah, look at that! So, Gareth, why is the crater that we just made so much smaller than the first?
Speed. That time the rosehip registered only 99 feet per second.
And what was the last one?
400.
The first rosehip hit the clay at around 120 metres per second. The second one was much slower at 30 metres per second, so it made less impact.
So the faster the travelling, the bigger impact, the bigger the crater.
Yes.
So, how can we now do the next shot and make sure we try and make a bigger crater than the first?
We need more speed.
How do we make it go faster, guys?
More powder.
Bob's doubling the amount of firepower in our cannon to increase the speed of the rosehip. Our final hit should be the biggest yet. Come on!
Go on.
Wow! Yeah! Look at the size of that! So how fast was that going?
That was about 240 metres per second.
That was double the speed of the first one. Which is why it's twice as big.
Twice as big.
So it's not the size of the comet that matters, it's all about the speed, because these rosehips were all the same size.
Absolutely. It's all about speed.
Our very own craters, the kind of holes a speeding comet might leave behind.
Ooh, cracking craters, boys!
Inspired by the Herschels, we've discovered our own passion for astronomy and the universe.
We've investigated Caroline's world of comets and seen the craters they can cause.
And now, inspired by Caroline's comets, we're going to reveal the genius idea.
Okay, right, here goes. We're gonna make our very own comet action movie.
Our genius idea to star in our own film in which we attempt to escape a comet heading straight for us.
Our challenge, to use what we've discovered to make it look as realistic as possible.
Our problem, we've never directed a film before. So instead of genius, it could be absolute rubbish.
To provide the special effects is genius helper Mark Turner.
Standing by.
In the past, he's helped us to do this. So a comet crater should be no problem. All right, Mark. Good to see you again.
Hello, friend of the show. All right.
Yeah. Right, today we are making an action movie. This is our storyboard, and we need you for this part, a crater.
Fantastic.
Well, we've been studying craters. We need a fairly big hole, kind of slopes over at the side, and lots of debris. Can you do that?
We can do that. Okay. Shall I show you how the special effects people do it?
Yeah, go on.
We take a mortar like this. We add
compost.
A bit of this vermiculite.
They look like little pebbles.
Cork. Simulate the stones and the rubble in there.
So we've got a soft, spongy mixture that's going to really fly high into the air, but what's actually going to be sending it up?
I think we should use gunpowder.
Look at that! Two!
I reckon about 1 kilo of gunpowder should do it.
This is going to be one mighty crater.
So,
right, let's build it.
Okay.
Comets disintegrate on impact, so our explosive effect must be big enough to leave an empty hole behind. Cheers then, Mark. While you're covering this over, we're going to go and continue with our movie.
Right,
see you in a bit.
bit.
Let's make a bit of a kind of city street here, so...
Okay.
Some of that. A little bungalow, look.
Very nice.
Where are you going?
Looks like a comet.
Oh, look, a telescope! Woohoo!
We just need one more thing for this movie to be complete. A little flame.
Yeah, right, Mark!
To recreate a glowing comet tail, Mark's built a genius contraption using fishing wire and a wooden ball covered in flaming cotton felt.
Oh,
yeah, nice.
Look at that.
Brilliant.
Hey up.
Mark's an expert, so don't try this at home.
We've just one more explosive scene to film in our Herschel-inspired action movie. But first, here's another tale about comets. It's the not-so-genius idea. The Deep Impact spacecraft has spent almost 9 years chasing comets, gathering incredible information on how they formed. Genius, huh?
No, because it's gone missing. Deep Impact's thought to have lost control, pointing its antenna in the wrong direction. Now it's a write-off, and NASA's given up trying to make contact.
Well, gosh golly darn it.
All right, so our movie is complete. Just one more scene to film now, which is the comet hitting our model city, leaving a massive great crater.
Here, defenders on. And you, Caroline? Ah, you've already got them. Right, Mark, push the button. In 5, 4, 3, 2, 1.
Stop! Spoiler alert. You'll just have to wait.
We've been on a brain-boggling journey with the Herschels, who helped unlock deep space.
We discovered how Caroline Herschel found new comets left over from the creation of the solar system.
And inspired by the craters they could cause, we filmed our very own comet action movie. And as we say in the movies, that's a wrap.
Caroline Herschel, you are an absolute genius, and our film is in honour of you. It's called Caroline's Comet.
Why, thank you, boys.
Enjoy the movie. Where is everybody?
I don't know.
I think I can see a comet.
It's all right, it's miles away.
No. Oh.
Oh, yeah, that's clever, isn't it? The way it's getting bigger and bigger.
Yeah. No, it's coming straight for us. Quick, get in the car. Right, go. Go.
Seatbelt.
Oh.
Floor it, Nicky!
Wait.
We've got to do something!
You're right, let's change the music.
That hasn't helped!
The road's closed. Handbrake turn.
Wow. I tell you what, that was close.
Yeah.
Oh, I've spotted another one. Now roll those credits.
Smack me in the face.
Doms.
Oh no! What are you doing? Let me get it straight. Oh, what's all that? What's all the black stuff?
Hey.